Hello everyone, and welcome to this first lecture in our Unity multiplayer course. In this lecture, we will be setting up Unity and importing the packages we need to be able to build our multiplayer game. So to start off, we're assuming for this course that you already have the Unity hub installed, and as for the version we're using, we'll be using version 2020.1. The patch that comes afterwards isn't really that important, so as long as yours starts off with 2020.1, you'll be good to go, and even if you're using a newer version when 2020.2 is out, or even off into the future, it'll probably be okay too. Then of course, for those of you who don't have 2020.1, head over to the blue add button, and it should be right at the top here under latest official releases. As you can see, mine's grayed out because I already have it installed, I've got the latest version, so just try installing the latest version for you. So once that's installed and you're on the right version of Unity, we can head over to Projects, click the little down arrow and make sure you select the correct version, 2020.1. We'll be naming this Multiplayer Basics because Section 1 is all about the basics of multiplayer, and then in Section 2 we'll actually be building a full game. So Multiplayer Basics. And as for the template, it's not too important, but I'll be using the Universal Render Pipeline. It's just a simple project setup, it makes the game look pretty good by default and it'll run on any device. Once you've filled this in and selected your directory, let's press create. Once your project opens up, it should look a little like this. And we don't need most of the stuff that it gives us in the template, so let's delete the readme, that's just this, we don't need it. We don't need the tutorial info. However, we do want to keep the settings. These are the graphic settings, we can keep these. It'll give us one script, the simple camera controller. We can get rid of that too, we don't need that, we'll be making our own later. And we can then go to the camera and delete the script. It says it's missing now, let's remove that so we don't get any errors. In scenes, we've just got this scene, that's fine. Presets, more settings we can keep for now. Materials, it has the skybox, I quite like this, we'll leave it for now. And then example assets is everything else in the scene that we don't need, so we can delete those. Then up in the hierarchy, we don't need the example assets anymore. And we can keep the post-processing and the lighting just how it is. It's up to you if you want to go mess with that, but I won't be doing it now. And now our project is ready to start importing packages. Most of the packages we'll be downloading are from the Unity Package Manager, and if you don't already have Mirror, which is the networking solution we're using for this course, most of you probably won't have it, we need to head to the Asset Store, which is now online only, so search online. And what we want to do is make sure you are signed in to the Unity website, okay, make sure you've got your face here, if not then sign in. Then search for assets, we want Mirror, like so. Here's Mirror. Let's move down a bit. And you need to make sure that you've got it to say open in Unity. Otherwise it might say, add to my assets or something. Whatever the blue button says, you should click on it. You'll get it, it's free as it says here. And then once you've got it, you can open in Unity. Then if you click on that, it will open it inside Unity. Otherwise, you can do it this way once you've added it. You can then go Window, Package Manager. And this is for anyone who already has maybe messed around with it. It'll be in Package Manager, My Assets, Mirror. Once it's in your package manager, you can then press import, and in a second it'll let you import it to your project. We want anything inside Mirror, but we don't want to mess with anything in script templates or streaming assets, we just don't need those. Future Nathan here, one quick thing to mention is that it seems they've removed the script templates and streaming assets from the Unity package, so if you just have a Mirror folder and that's it, then you can just leave it as it is and hit import. So let's import this as it is, and I'll be back in a minute. Once it's done, you can close the package manager and you'll see a Mirror folder inside your assets. And then up in the hierarchy, we can make an empty game object, and let's just chuck on a network manager. Okay, you see here, all these mirror icons, the blue squares, lets you know that it's imported correctly. Let's remove that, we don't actually need it. And let's move on to importing the other packages. To import the other packages, we head back to the package manager and we can switch to in project, and that'll show you all the packages that are currently installed. Now, you don't have to do this, but what I'll be doing is I'll be removing the packages we're not going to use. You could just leave them in there if you'd like, but I'm going to be removing those. I'll be updating any ones that need to be updated, and then adding any new ones. So the first thing we'll do, actually, we'll start adding the ones we want and then remove the other ones. So head over to the Unity registry. This gives you all the packages you can get, but we want to enable preview packages because one of the packages we'll be using is not actually on this list because it's in preview. So the way you do this is you head to the cog, Advanced Project Settings, and check Enable Preview Packages. Say you understand that they're in early development, okay, and you see some preview packages. We want to add ProGrids as our preview package. Here we go, ProGrids, install, and give it a second. Resolving packages, importing, and then any second now it should be done. Once this is done, I'll show you how to do one of the other packages, which is the input system. This one takes a little longer because it has to actually restart Unity, so obviously I'll be skipping ahead for that part. And then for the rest of them, I'll be giving you a challenge. So let's go find the input system. Obviously, it's easier just to type input system, install. And if we give this a second, it'll actually ask us, as I said, to restart Unity. You'll get to this point with a warning that says the new input system will disable the old input system that will require you to restart the editor. Yes. So Unity is back open, and now if we search for input, you'll see it's got a tick, it's worked just fine. And I'll be giving you a challenge in a second to actually import the remaining packages, as well as if you want, you can remove the ones that we don't need. So I'll be giving you a list. Some of them you'll already have installed, you can ignore those. Some you haven't got, and some you will have that you don't even need, so you can remove them if you'd like. Here's a list how it is currently. Remember, to add new ones, you have to go back to the registry and add them. And to remove, you just click and then press remove here. So back to the registry. The things you need to import are as follows. So we need to import the remaining packages. Cinemachine to work with cameras. The input system, which we've already just done. ProBuilder and ProGrids work together for helping us build our level quickly, and obviously for ProGrids you need the preview packages, but I've already gone through that with you, just in case you forgot, there it is. TextMesh Pro should be already installed anyway. Unity UI should also be installed anyway, but they've made that a package now, so I put it on the list. The Universal Render Pipeline, that came with our template, so that's really down to whether you want to use this template or not. And finally, the Visual Studio Code Editor, for those of you who are using Visual Studio Code like me. There are some other editor plugins like for Rider and Visual Studio Community Edition, so it's up to you to get the one that matches which version of IDE you're using. So go ahead, pause the video and have a go at getting your packages to look like this. Welcome back, I hope you paused the video and gave that a go. Let's head back over into Unity. I'm going to do it as well, and I'll time-lapse it so it doesn't take forever, whilst also talking about packages in general for those of you who aren't used to adding all these kind of packages. So the reason we're using packages and why Unity made it like this is because we don't actually want some things in all our projects. Some projects want some things, some want others, so it allows us to add and remove what we either need or don't need. So for example, the UI, you'd think most people need UI in every single game, but keep in mind Unity isn't just a game engine, it might be used for film, and in film there might not be UI, so just remove that package, right? For all these different packages, you need them in different scenarios. So it allows you to, when you need something, to add it. So throughout working on a project, you might decide you need timeline, so you can just add in timeline. And it means that you only have the stuff that you need when you need it, and it doesn't clutter up your project. And now that's done. So we have Cinemachine, Input System, ProBuilder, ProGrids, TextMesh Pro, Unity UI, Universal Render Pipeline, and the Visual Studio Code Editor ready to go. And for those of you who are using the Visual Studio Code Editor, then we can head over to Visual Studio Code. The two packages I'll be using is a C# package here and the debugger for Unity. It's only these two. And one last thing is that now that we have the ProBuilder and ProGrids packages, they both have their own bits of UI. And if you continue watching the course, you might notice, in some lectures, bits of that UI might be on my screen. And you don't have to worry about it not being on your screen. It's not going to affect anything. We're not using it till very late on in the course when we do some level design. So if we go to the scene view, you might notice this, you might not. And it doesn't matter if it's here or not. You can close it if it is and you don't want it. You can just ignore it. If you do want to know now how to turn it on, you just go Tools, ProGrids, and you hit ProGrids window to turn it on. And in ProBuilder, you can turn this on. And like I said, they're just level design tools that we'll be using later on in the course. We've just installed them now so that we don't have to come back later and do more installation. So if they are there, you can ignore them, and if they're not there, don't worry. And that's it for this lecture. We've made sure everyone's on the right version of Unity. We've installed any packages that we need and got rid of any things that we don't need. I've made sure that anyone using Visual Studio Code can follow along with the right add-ons, and we're ready to start building our multiplayer game. Hello again everyone, and welcome to this lecture where we'll be covering the client-server model. We'll be starting off with some theory about how it all works, and then moving on to a practical example of building our game using the example Pong game given by Mirror, and then connecting a client to a server and being able to play Pong against each other like you see here. So I know you're eager to start making your own multiplayer game, but before we start making anything, we need to actually understand the theory behind multiplayer games. Now over this course, we'll be covering lots of different parts of the theory, and for this lecture, we're going to be covering the client-server model. So what normally happens in a game when you make a normal Unity game, a non-multiplayer game? What happens? Well, you have state, and state is just data. The data could be about where your player is, it could be about how much health they've got. It's all the data that all the game objects store inside their components. And then you have actions. Actions usually input. So for example, pressing the spacebar. Now pressing the spacebar may change the player's velocity on the y-axis because they're jumping, they're going up. So by pressing space, you can change your state over the course of an update tick. So for example, in your update, you could be checking for actions and changing state accordingly. And then because of your action pressing spacebar, your state now changes. So state 1 becomes state 2. So it's the same variable, but it's changed the value. And that's what might happen in a non-multiplayer game. Now for multiplayer, there's two kinds of connections. The first one is peer-to-peer, and then we'll be moving on to the client-server model, which is what we'll be using with Mirror on the next slide. But for this one, how peer-to-peer works is you have your different clients, so these are the different players in your game, and they're all running the game on their machine, and they are all connected to each other. So player 1 here is connected to player 2 and player 3 and player 4. And each one of those other players is also connected to each other. And when I do my action, for example, pressing the spacebar key, I tell all the other clients that I press the spacebar key. And then they all update their own state internally, as well as me doing it on my own. And the problem with this is there's a lot more data to send out for you, right? So you, whenever you do something, have to tell all the different clients in the game. And then whenever they do something, they have to tell everyone else. And another problem is when I press the key to do spacebar to jump, then I have to wait for it to actually tell everyone to do something. So it now is as slow as the slowest connection. So if one of your friends has a really bad connection and the other three are really good, it can really mess up the game. And then the other one is client-server, which is what we're going to be using for this course, and it's what most of the games you play will be using, at least more competitive games will be using client-server. Some of the more fun, casual, play with friends games might be using peer-to-peer, but most will be using client-server. And how client-server works is, you have your different clients just like before, but you also have a server. And that server is where everything is authorized, everything is sent to and sent from. So instead of me telling all my other players, all my other clients, what I'm doing, I just tell the server. I tell the server I want to jump. Then what the server does is, it updates its own state. So the server is storing where my player is and what their velocity is, for example. And then once it's happy with that, it can then broadcast it to all the other clients, including myself, for validation purposes. So with having a server like this, it means that, let's say the players jump, they can only jump when they're on the ground. Rather than me determining whether I'm on the ground or not, the server decides that. Because if my client decides whether it's on the ground or not, I can then hack the game very easily, I can then cheat and just jump forever. I could, make a modified version of the game where I just don't have a grounded check and I can fly, basically. So all the authoritative logic needs to be on the server, and then it can tell everyone else what's going on. It's a really good way to stop cheating, and it's also easier for you as a client to not have to send data to all the other clients. You just speak with the server. There's one connection there, you to the server. You're not connected directly to the other clients. It's also a lot safer. So we just covered what clients are and what servers are. But there's one other thing we'll be getting used to a lot, which is a host. And a host is nothing extra. It's just a client and a server combined. So right here, the server might be hosted somewhere, over at some game company's headquarters, right? They might have their game servers. You as clients all connect to that. What a lot of games will do, usually for custom games, is they will assign one of the players to be the host. So there's still not peer-to-peer. Player 2 and player 3 aren't connected to each other, but they're all connected to player 1. Player 1's machine will be running a client for the player 1 to actually play the game, and a server that's on their machine for everyone to connect to, including themselves. So it still works, all the code is the same as a client server, it just means that the server is hosted on your machine as opposed to somewhere else in the world. And there we go, that's enough theory for now. I know you're here to start making multiplayer games, which we will be doing over the next few lectures. We'll be doing some coding. For the rest of this one though, we'll actually put this theory to the test. We'll host a server for Pong, and then connect two clients, and then play against ourselves on our own machine, but running different instances of Unity. So if we head back over to Unity, if we go to the Mirror folder, there's an examples folder with these examples you can give a go. We're going to be trying Pong. If we head to the Pong scene, like so, we can hit play, and we actually get some UI pop up to either host be a client, or be a server only. Now, just like the theory I mentioned, we can be a server, in which case we just exist like this. We're not actually playing the game, we've got no player, no input or anything. We just host the game server. Then clients can connect by doing client. And this is an IP address, a network address. We'll be covering that in a separate lecture. It's a whole nother thing to get into. For now, all you need to know is that localhost is the IP address of yourself. So rather than actually having to put in any numbers or anything, we can just write localhost like this, and it'll connect to ourselves. Or we can become a host, which will create a server like this. It'll basically do server only, then client. It's just one thing, right? We become both. A host is a server and a client. Now, if we do that, it'll kind of work, but there's one problem, which is down here. It says the input system problem. And that's because in the previous lecture, we enabled the new input system, which in turn disabled the old one. And this mirror example is actually using the old input system. So how we can do this, how we can make both work, is if we stop running, we can go to File, Build Settings, and while we're here, let's remove the sample scene, which is the scene we had at the start. Remove that, and we want to add this open scene, which is the Pong scene. And then we can go to Player Settings, and we want to put this in windowed mode. So from full screen window, if this is closed, it's like this on the Player Settings, Resolution and Presentation. Change it to windowed, and put it something like 1280 by 720. So when we run the build, we can see both at once. We can just have a small window to the side. And then in other settings, scroll down. Active input handling is on new, so it means use the new input system. We changed it from using the old. There's actually an option to use both, and that's what we want for now. So let's use both. And it'll actually ask you to restart the editor. So if you press apply, we'll have to do that. So I'll see you in a second. Now it's back open. If we close this and hit play, we should be able to host the game, so being the server and the client. Let's maximize this. And if we press W and S, or up and down arrow, we can move our player. But the game hasn't started, there's no actual Pong ball, and there's no player 2. So that's the final part of this video, is to actually connect the other player. So how are we going to do this? Well, we're going to host and join your own game, or you're going to do that by building the game, starting as a host, like I showed you, starting as a client, the address is already filled in, and have a go and play the game yourself. So this is where you should pause and give it a go. If you don't know how to build in Unity or do the other things, don't worry, in a second I'll be coming back to show you how to do it all, but pause the video and have a go at doing this and play the game against yourself. Okay, I hope you paused the video and gave this a go. Let's head back over into Unity. So how we do this is we go File, Build Settings. We've got the right scene here, so we can press Build. We need to give it a folder, so I'll make a new folder called Builds. And we'll select this as our folder. And then if we give Unity a second, it's going to build our game. And I'm just going to skip ahead to when this is done. Once it's done, it should open your folder here, showing you where the build is. So what we can do is we can run this executable, and it'll open us a Unity window, as we see here. This is going to be our client, our external client. And we can then press play in the editor. So we're running both these instances of the game. And we want one of these to be the server and client. So one of these is going to be a host, and one will be the client connecting to be player 2. So let's make the editor the host. There we go, player 1, and it's in. Then we can connect as a client on localhost, and then the game starts. And I can move up and down player 2, and you actually see up there in the editor, my player moves up and down. And then if I go into here, I can move up and down and play, and I can tab back, and I can tab back. I can tab back and play against myself, right? You see the point. Now, this is just an example game. There is no scoring and winning and losing. The whole point is it's showing you syncing your input, player position, and so on and so forth. So yeah, that's it for this lecture. I hope you enjoyed and learned something new about client servers, how multiplayer games work with networking. In the next few lectures, as I said, we'll be getting into the coding and actually writing our own multiplayer logic. I hope you're looking forward to it, and I'll see you there. Hello everyone and welcome. In this lecture we'll be covering the Network Manager, which handles all the heavy lifting for servers and clients for sending data back and forth, and it allows us now to write our own custom Network Manager to do this. We can host and get a player object, our own custom player object in the scene, and log saying there's now 1 player and I connected to a server because this is a host, it's both. Can move it to the side to make space for the next client to join, and the client will then see both. And if we look in the logs, now there are 2 players. So we can do all this thanks to the Network Manager. Let's get into the lecture. So the main focus for this lecture will be the network manager, which is a component given to us in Mirror that handles all the heavy lifting for starting a server, connecting clients, and the whole data transfer that happens during your multiplayer game. And regardless of what genre of game you're making, regardless of what it is, you still will need a network manager to host your server and connect your clients. So if we look over here, the network manager Pong script has been used in this example from last time. And there's some various things on here that we will be using in our own, and I'll be going through them any minute now. And then there's some specific things for their game, like the racket spawn points and the ball. So to do that ourselves, let's head back over to our own scene by going to Assets, Scenes, and Sample Scene. And before we forget, let's head up to File, Build Settings, and remove the Pong scene from our build, because we want to be building this scene when we test it later. So add Open Scenes, and it'll add the sample scene. So I think the first thing to do with the network manager is to just have a look at the default network manager. So we'll do that by going to our hierarchy, right-clicking, and create an empty game object, and then I'll rename this to Network Manager. And then we'll click on the Add Component button and type in Network Manager, and add that. So the network manager has many variables, many things you can change, and if I went through every single one, explain them all in depth, we'd be here forever, so I'll just be covering the ones that are really important for what we'll be doing. So we need to make sure Don't Destroy on Load is turned on, so that when we change scenes, when we add levels, your game might have different maps and things, you will be changing scene probably, so that this object doesn't get destroyed. If it gets destroyed, then the server closes, all the clients lose connection, and everything goes wrong. You need to make sure it persists beyond the scene change. Then the next thing is arguably the most important, which is the transport. The transport is all about how the data is sent between the clients and the server. Now, since this is Multiplayer Basics Section 1, we won't be going too in-depth into how this all works. We can cover it in Section 2. For now, all you need to know is that this component it's referencing down here is the thing that handles the data going back and forth between clients and the server. By default, it uses something called telepathy, and there are others. If we were to search transport into the components search, then we'd see here we have fallback, LL API, multiplex, telepathy, WebSocket, and there are actually others you can go get. You can make your own. Steam has one. We'll be using that later on in the course for the Steam connection section. So just know that for now, we're using telepathy as the default way to send data between the clients and the server. Next, we have the network address, which is who we're connecting to. By default, it's localhost, so we'll be connecting to our own network. And later on, I'll be showing you how to connect to other people on other machines, or get your friends to connect to your machine. Max connections will just simply not let more than 4 people join the server, quite simple. And then we have the player object, which is very important. The player object is what holds your existence in the server. So whenever a client connects and the server validates it, it will create a player object for you off this prefab. And that's where you can store your name and team color and money and whatever else you need to store, your points. And if you don't have that, then it's going to cause problems. Whenever a client spawns in, it'll spawn in this prefab for all clients, so you can actually get reference to other people's team colors and names and things like that. So it needs to be on all clients. It needs to be a networked object. So let's make it now. It's quite simple. We just need to make an empty game object, and we'll just call it player. And we just need to click Add Component, and we want to add a network identity component. And this is just a component that you stick on things when you need it to be networked. And what I mean by networked is that if you go back over here to the network manager, it'll say the player prefab must have a network identity component. It gives it an ID on the network, and it lets the server keep track of it. The server keeps track of network identities. So if we didn't have this, it wouldn't even allow us to set it in the network manager. And we need to make this a prefab so we can keep spawning them in for all the clients. So let's make a prefabs folder by clicking Create, Folder, Prefabs, head into Prefabs, and click and drag the player into there. Then we can delete them from the scene, and we can drag in the prefab to the player object here. And auto create player means, go on Mirror, when someone spawns in, just create the player object. If you turn that off, you can then write your own custom logic for what happens when someone joins. And random is just where they spawn in the scene, which for now will just be at the center of the scene. We can actually add in these game objects as like little markers as where the player spawns, but we won't be worrying about that right now. We'll just spawn in some players and see them in the scene. And just for the sake of having some visual representation of them, because the player's not going to die in this example, we're going to just quickly add a sphere to the player, and there we go. So if we went to the prefab in the scene, we'd see over here, we have the player. So when they spawn in, obviously, we'll be able to see them in the world. If I go over to the game view, we'll see them here. The camera is not quite set up right. I could just, reset this and just move it about a little bit with the gizmos, dragging it back and up, tilting it down, and then heading back to the game view. And now we've got our player. So then obviously we'll spawn in more players and we'll be able to just move them around to see them all in the scene. So the next thing I think we should do to prove it all works is to delete the player from the scene. We'll head over to the network manager, and I'm pretty sure everything on here is set up. And we want to add one more component, which is the network manager HUD, so that we can see the little bit of UI in the corner that lets us join. So we'll add to here the network manager HUD, it's down here. And just by adding this, when we hit play, we'll now see the UI in the left corner where we can click start as server, start as client, or host. Let's go up to the top, hit file, build and run, and I'll be back in a minute. Now that Unity is ready, let's host it as a server and a client. And we see the client appears here, the player object. And we can move that to the side so that if we join as a client on here, it will spawn in and we can actually see them both. So you see you've got player here and player here, representing each player. And one other thing is, you'll notice when we spawned in this instance, we see that player 1, or the editor player, is on the left. And that's only because they were there when we connected. But we don't actually have a way right now of syncing positions. We don't do any of that. So if we were to move this object now in the editor to the right by dragging the X, we won't see that reflected in here yet. So we'll be covering that in a future lecture. But you see the fact that when clients join, we can see them. And when they leave, they go away. Now that's great and all. We're using the network manager we're given. But games have, their own custom logic. When a certain number of players have joined, the game starts. That's quite a common thing. Or maybe you just want to log something out whenever a client joins. You want to say, hey, this person joined, or hey, we're on this many players now. You can write your own custom logic. And where do you do that? You do that in the network manager. But there's a problem, obviously. The network manager is some code written by Mirror. And we don't want to edit that. We don't want to mess with any of that because it's all done for us. And if they ever update Mirror, it'll update that network manager. So we can't start tinkering with that. So we need to make our own network manager. So let's head over to Assets, Scripts. If you don't already have a scripts folder, go ahead and create a new folder for it. And inside here, we want to make a script for our network manager. And we can call it, they called it Network Manager Pong, so we can call it Network Manager, or like My Network Manager. We'll go with My Network Manager, and we'll hit enter and create it. And then we'll open it up inside Visual Studio Code. You'll notice when we make the class, if you're used to using Unity, it'll actually make it as a mono behavior. We inherit mono behavior. And all inheritance means is that our class here gets everything that this class has. And then if this class inherits something, so let's hit F12, which it does, this inherits behavior. So the mono behavior gets everything that behavior gets, and it's kind of like a tree. It's like a tree that branches out. So we are inheriting mono behavior, which just means we can stick this onto a game object, and there's a little bit more there we don't need to worry about. But our own custom logic is non-existent right now, and we can get rid of these. We can get rid of these functions we're given. We don't need them. The problem with this is it's not a network manager. We've called it My Network Manager, but if we head into Unity and we stick it on the game object, it's not going to work very well. This network manager is relied on by the network manager HUD, so we have to remove that first. We'll just remove each of these individually and then add it back. So we'll add My Network Manager. But it has nothing there, right? We expect all the stuff about the offline and online scene and the player objects and all these other things, they're all gone. And that's because we need to inherit from the network manager. And to do that, we go back into our code and we'll change mono behavior to be network manager, like so. And it says, red underline squiggly, it doesn't exist. So if we hit control period or control dot, it recommends that we should be using Mirror. So let's using Mirror. And there we go, it's happy now, no problem. So if we save our code and head back into Unity, magically we gain all, well, it's not quite magic obviously, but we gain everything that the network manager has. And then we can build on top of it. That's the main thing here. We get all the behavior about connecting clients, hosting servers, data transfer, and all we need to do now is write our own custom logic for what happens when people join the server, when people leave the server, when the server starts up. We can do whatever we like. Let's make sure this is all set up correctly. I think the only thing here that isn't is the player prefab. It's lost connection now. So let's go to our prefabs. Here's our player prefab, and then click on the network manager and drag the player in. There we go. That's all sorted. Save our scene. And now we want to write some more code. We want to write some logic for, what happens when people do things. So what we can do is we can look inside the network manager, and it's a lot of scary code. And obviously you don't need to worry about this. It's all written for us. There's lots of variables at the top. If we jump down a bit, there's methods here like start server. There's so many things. And one thing you'll find is these things called virtual functions. And all you need to know is that a virtual function means that it can be overridden. It means that the behavior that the Mirror devs have written for us here, we can say, actually, no, when you server change scene, don't run this, run our own code. So that's really useful when we want to say, when someone connects the server, do this. And I'll be showing you how to do that in a second. But if we want to run this code that they've written and then our own code, we can also do that too. We don't have to copy paste this and write it back in here to ruin our own code. Before we write our own logic in the network manager, let's just have a look at the theory behind what goes on. So there are two scenarios. There's the client scenario and the server scenario for when a client is connecting to a server. So this is what happens for a client. A client will attempt to connect to a server, and then certain things will be called on the client. We'll have the onStart client and the onClient connected callback. And what these do is these are just methods that are called, and we can do our own custom logic when they happen. Now, onStart client always gets called whenever you click the client button when you try and start a client connection, whereas onClient connect only gets called once you've connected to a server. That might not always happen. There may be no server there for you to connect to. So you might start a client, but then not client connect eventually. That only happens if you successfully connect. And the way this goes is that it just goes simply like this. That one happens first, and then the onClient connect happens second. This doesn't mean these methods are called on the server. It's just a flow diagram of the sequence of events. Client connects to the server, then onStart client is called, then onClient connect is called only if you successfully connect to a server. So that's what happens when a client connects to a server on the client. But what happens on the server when that happens? Well, the client will try and connect to the server, and then there's various things that will happen on the server afterward. These are the main things. So the main thing that happens first is there's a callback, just like how we had on client connect, that's called on the client when it connects. There's now a callback called on server connect, which is called on the server when a client connects. So the on server or the on client at the start simply tells you whether this method is called on the client or on the server. Then the bit after that tells you what the actual event is, what is happening. So connect is just meaning clients connecting to servers. So you get a callback saying, hey, a client's connected. Then once they've connected, there's a little period of time before they are ready for data transfer. Once they are ready, then on server ready will be called. That's just another callback if you need to do something then. And then this isn't a callback, but one thing that happens in Mirror is that it will create our player object for us. So that prefab we made, it'll spawn that in and set that up for us. It'll create the player. And once it's finished with that, it'll then trigger another callback for on server add player. It'll say, hey, we've now added this client, this connection that came in, now has a player. All right, let's head back a little bit. So if we go back, you'll see here, when a client connects, the client will start client and then do a callback for on client connect. And that's where I'm going to show you how to actually write your own custom logic for when a client connects. If we head back into Visual Studio Code, remember in the network manager, there's some methods marked with virtual, and that means that we're allowed to override them to write our own logic to replace that or to add to it. We can either add to their logic or just replace it. And in this case, we want to add to it. So I'm going to say public override, which is the keyword when you're overriding, and then void because we're not returning anything. And if we start typing on, we'll get all the on callbacks here. And we want to do on client connect. So let's click that and go here. So by doing this, if we hit F12, the F12 key on override, you can actually see the logic that would normally happen. And we don't even want to bother thinking about this, Mirror's been written for us, we're using Mirror. We want to write our own logic as designers. We don't care really what they do unless you really want to get into the nitty gritty and mess with it. So let's just say, basically, do all this stuff and then do our own custom logic. So the way we do that is we need to say, do the base logic. Do the logic you already meant to do. So base.onClientConnect. and it still needs the parameter, so we just pass a connection into here. So right now, this method is just as good as if it wasn't here. It is just calling the base logic as it would normally. To make this, useful, we want to write our own logic, such as logging to the console saying, I connected to a server. And now we're saying, okay, yep, when a client connects, do what you normally do and log to the server. So now when a client connects, we're saying, do what you normally do and then log to the console saying, I connected to a server. Let's give it a go by going back to Unity and make sure that on the network manager, we need to go back here and we need to actually add the HUD back. Otherwise, we won't have any easy way of connecting to the server. So the network manager HUD. Once that's ready, we can build and run. Let's open up the console. And if we host in the editor, you'll see the player exists. And now it says I connected to a server. If I connect on this client, we won't see that log because it's technically getting logged in this client. The editor won't log for me. So if I connect, nothing else happens. But it still works the other way around. If I was to host over here, let's start a host and then join as a client here. By joining as a client, we then log I connected to a server. The base logic happens for connecting to a server, and then our custom logic happens right afterwards. And now I want you to have a go at this challenge. Let's have a look. So the challenge is to log on the server whenever a player is added. What that entails is overriding the method on server add player, remembering to call the base method so we don't miss out on what would normally happen. Then use debug log to write the message to the console. You can say whatever you like. You can say a player was added. If you want to get fancy, you could, try and find out how many players there are and log that in the message saying there are now 2 players. I'll be doing that with you in a minute. Just log a message whenever someone connects to the server and the player is added. Then if you want to know how many players there are on the server, you can use the numplayers property. That'll give you an integer for the number of players, and then you can add that to your string to display there are 2 players, for example. Have a go and pause the video. I'll be back in a second. Okay, hope you paused the video and had a go. Let's have a look at how we do that. So we can go public override, just like we did earlier, void, and then it's a server method. And as we said, it's on server add player. And all we want to do is make sure we do the base method. So base.on server add player, passing in the connection, and then writing our own custom logic. So I'll just copy paste this debug log and change the message to say, a player was added. And that's how you do it. So now the server will log a player as added whenever a player is added. Now I could build and run and test that, but I can assure you it will work. We'll actually check it in a minute, but I'll make this a bit more interesting. One thing we can do is we could log how many players there are now. It's a bit better than just a static message of a player was added. So to make this string go from being a static string that never changes to being dynamic, we can stick the $ before it. So this is a feature in C#. I don't know what version exactly was added in, but it's been around for quite a while now. And you might be used to doing strings with pluses, so you could say a player was added plus and then another string, and that would work. But I prefer, and I also think it's now the more common option, is to do the $ method. So if you want to add a variable into your string, stick a $ before it, and let's change the message to say there are now, and then a certain number of players. So in this gap where we want to put how many players there are, so let's actually first of all make this say players. When you want to put a variable in, you put it inside curly braces, and then you just put your variable in. So it could just be the number 5. It's pretty boring though. We want it to be an actual variable, which is the number of players on the server. And that's actually a handy property we have access to in the network manager. We can just say num players. Save. And there we go. The number of active player objects on the server. Obviously, this is only valid on the server, which we are on here. We're on the server. So we can now say, here, log a string, and the string is there are now, and then inside here, it will grab the variable num players, which will be a number of maybe 1 or 2, convert it to a string, and then we've got our string. Remember, to do this, you need $sign before it, and we can now go give this a test. So now it's built. Let's have a think about what will happen. If we click host in the editor, it will start a server and connect a client. So it should technically log, if we look back at the code, remember, it should log I connected to a server and the fact that there are now a certain number of players. So it should log both of those. Let's test it, hit host. So it'll say there are now 1 players, and then I connected to a server. And then what do we expect to happen if I connect as a client in the build? we expect it to say there are now 2 players. Hit client, and there are now 2 players. And remember, they are both here in the inspector. If we were just to move them along, you'd see them both here. And that's it for this lecture. So now you've learned how to use the network manager to host the server, connect the clients, and write your own custom player logic for when those things happen. And there's plenty more callbacks we haven't covered, there's so many of them, and you just really use them when you need them. Most of them you may never use, but you'll find there's plenty of them that you will use, and we'll move on to using more throughout the course. That's it for now, and I'll see you in the next lecture. Hello everyone and welcome. In this lecture we'll be covering network behaviors and SyncVars, which is all about how you can synchronize data between the server and the clients, such as their name and their team color, and plenty of other things throughout the course. But in this example here, you'll see we can host here, and we can join as a client in the editor. And if we look at the player objects, we actually have been assigned a name of player 1 and a color of purple, and player 2 has a name of player 2 and is assigned pink. And if that client was to leave and rejoin, they'd be assigned a new color. Obviously the name is player 2 still because they are the second player in the server, but their color has changed and I can keep doing it and it keeps assigning a new color. And if we were to join again on another client, they'd be player 3 with their own color. So this is all decided on the server over here. The server is generating those colors and syncing them across to the clients. So let's get started talking about network behaviors and SyncVars. Now, both those things, you may not know what they are, so let's get into some theory. So what are network behaviors and SyncVars? And by vars, I mean variables, but it's what it's called in Mirror. So imagine this, we have a server, and there's an object on it, it's a green cube at position 10. And then we also have a red cube at position 10. And then when the client connects, they are loading the same scene. So by default, just by loading the same scene, even if these objects aren't, sent over the network, you'll still have the exact same setup, where the client will also have a green cube at position 10 and a red cube at position 10. But obviously, in a networked game, stuff happens on the server and then you need all the clients in the game to receive those updates. So what we can do is we can mark a game object as networked. So the way you do this is by, on your component, you would change it to inherit network behavior instead of mono behavior, and we'll be doing that later in this video. And by doing that, you say this component is networked, and therefore the game object it's on is networked. And then because of that being there, nothing special really happens immediately. It just is a way of marking it for being networked. And then what it allows you to do is it allows you to then mark certain variables on that component as networked variables or SyncVars. What it means is if that variable is updated on the server, it will then be updated on all the clients. Now there are some limitations as to what kind of variables you can and can't sync, and we'll be covering that as well. But let's imagine it's just an integer like this position here. That's definitely something you can sync. So we update the position on the server to be 20. And because it's a synced variable on a network behavior, what it does is it will then automatically in Mirror tell all the clients connected that for this green cube, the position has updated from 10 to 20. And then on all the clients, it will receive that update, and then it will update their own internal state saying the position of this cube is now 20. And therefore, when something happens on the server, you then see it happen on the client. So the theory for this video is very simple. It's basically this. As we say, we have components that are networked, and on those components, we have variables that are networked, that are synced. And when they update on the server, they then update on the client. So let's head back into Unity and get started. So what we want now is a way for the server to be able to assign names to all the clients, and then to have those names synced so that all the other clients see who is who, what their names are. And then in a future lecture, we can set the names ourselves, so we can say, I want to be called Dapper Dino or whatever, and then the server will validate is that name valid, and if it is, then it'll set it and sync it with all the clients. But for that to be possible, we need somewhere to actually store this data and somewhere to sync it from, and that's in a network behavior like I mentioned in the theory. We need a network behavior, and then we can put SyncVars in there to sync variables. So let's head to our scripts folder, and right-click, create a new C# script, and this is where we'll store that data to be synced, and it'll be called my network player. So that's where we're going to store our player name, and later on in this lecture, we'll be storing our team color or our player color. So now open it up in Visual Studio Code. We have my network player, which is a mono behavior. But as I said, it needs to be a network behavior to allow networking and to allow syncing variables and all the other fancy things that come with Mirror. So to do that, we just change what we're inheriting to be network behavior. And for this, we also need to be using mirror. So hit control period and hit enter. And we're now using mirror. We don't need any of the start and update logic. Let's get rid of that. And now we just have ourselves an empty network behavior. This allows us to stick it onto a networked object, and not much else will really happen now. Under the hood, it'll be tracked. It'll have some kind of ID to store, this network behavior belongs to this client, but nothing else really happens because we haven't written any logic. Obviously, we're going to write some in a minute, but let's head back into Unity and put this on our player. 1, so we don't forget, and 2, so I can show you something else. We go to our prefabs player, inspector, and let's add on the player, or my network player. And it seems normal, right? We've just got our my network player script, but because this is a network behavior and it's a networked component, it needs to exist on a networked game object. And you know it's a network game object because it has the network identity component. And if we were actually to try and remove this, it wouldn't allow us. And if we removed the network player and then the identity, but then added back the network player, it would add both, because this component relies on this one. You can't have the network player now without the identity. And just to make sure the network manager hasn't broke while I was doing all that, nope, we've still got reference to our player prefab. So we're good to go. Now we can start coding inside the network player. So like we said, we want to sync the player's name. So to do that, we need to make some string variable to store it with, and we also want to be able to sync it. And the way we do that is we want a synced variable, so let's add the SyncVar attribute. Like it says here, if you put this before a field, then it'll say SyncVar is used to synchronize variables from the server to all clients automatically. So simply by changing the value of the field on the server, all the clients will then in time receive the update. And as it says, the value must be changed on the server, not by clients. So it's also going to be a serialized field because we want to see it in the inspector. And it's a private, a private string display name. And we'll give it a default value of missing name. Just in case something goes wrong when setting the name, at least you'll still have a name of missing name. And that's great and all, but we currently don't have a way to actually change it. There's no code in here to change it, and we can't change it in the network manager because there's no public way to access it. So we want to make a public way to access it. Let's make a public void set display name. That'll take in the display name, so it's a string, new display name. And then what we can do is we can say display name equals the new display name. And now this method is only ever going to be ran on the server. The server is the only one that can do this. So what we can do is we can add this handy thing called the server attribute. This isn't necessary, we don't actually need this, but it's to protect us from ourselves. It'll stop clients from running this method. If we accidentally somewhere else in our code call this on a client, it won't even try and change the variable. It'll just stop saying, hey, you're not the server, you can't do this. It'll print a warning to the client, to the console, sorry. So it's pretty good protection there. And now we just need to actually call this in the network manager. Let's head over to the network manager. And now we need some way to get reference to our player. How do we do that? Well, this connection on the server is the connection to the client. So this is when the server adds a new player. This is their connection. So from their connection, we can actually grab their player. The way we do this is by typing con.identity. Okay, con.identity, if we look in Unity, and we go to the player prefab, we already have it open. Let's go to the prefab view for this. Okay, so we've got the network identity here and the network player script. You'll notice these extra things have appeared for the sync settings. This is how often we check to see if this variable has changed. So if this changes every 0.1 seconds, every 0.1 interval, it will check if it's changed, and if it has, it'll then sync it. But by saying con.identity, it's actually going to refer to this network identity here. Since this is the player object, the .identity is referring to this identity here on the player object. And then from here, we can get reference to the network player by saying .getComponent my network player. So now we've got reference to our network player. We want to store it. So let's say my network player. Now what this allows us to do is to call methods in the my network player script whenever a player is added, and this is a good place to set their name. So let's say player.setDisplayName, and then the string, we'll use the $sign again. We'll call you player and then num players. So when you join, you're the first player, you'll be called player 1. We can now get rid of this log because we've got a better example here. we simply do the base logic for when someone joins, we grab their player component, and then we set their name to be player 1, player 2, player 3. And we don't really need the onClient connect anymore, so let's get rid of that just to clean it up. And now we have a nice way to set the player's name when they join. Then by setting display name, we head over to here. It sets the name on the server, and it's a SyncVar, so this is now synced to all the other clients. Now there are limitations to what you can and can't synchronize. So on this lecture, there is a resource, and I can show you it now quickly. We have the data types, which tells you here what is and isn't supported. So the kind of default types you use all the time here, like strings, ints, floats, these are all syncable, so you can easily just shove on a SyncVar and it will work. Same with vector freeze, quaternions, recs, quite a lot of the common built-in Unity math types. And there's some extra things here, such as structures with any of the above. So we're going to be syncing color for the team color. And since that is just a structure of floats, we can sync the RGB values of that color. Let's head back into Unity and prove that this all works. What we'd expect is we'd expect to run the server, run a client, and the client to get the right name. And if we run 2 clients, we expect the first one to be called player 1 and the second to be called player 2. So we can file, build and run and see what happens. Now that the build's ready, it won't be that impressive if we were to host in the editor and then join as a client here, because the variables are being set on the server normally. So if we checked if that had worked, then that's nice and all. But we really want to check if the syncing works. And since the code we wrote runs on the server, let's make the server this built client by hosting. So we expect to have a player 1 here. And if we join as a client here, what we want is for those variables to be synced across. So if we press client, we have our 2 player objects. One should be called player 1 and the other should be called player 2. Let's have a look. Click here, player 1, go down, player 2. So it's synced. And that's cool, we're syncing the name. And now for your challenge, we're going to try syncing a color. So we want you to create the color variable using the color type. Store that inside the network player, just how we stored the name. Add the SyncVar attribute so it syncs it, otherwise you will be wondering why the client isn't receiving the updated color. Assign each player a random color on the server. Now this might be a little bit advanced if some of you don't know how to make a new color and make a random color. So if you need a hint, if you don't need a hint, you can pause here and have a go. But if you need a hint, to make a new color, you simply make a new color. And then inside you need to pass in 3 values. So randomly generate each of the RGB values between 0 and 1. And for those of you who don't know how to generate random values, another hint here, the final hint, is to make a random value, use random.range, and then you pass in the lower bound and the upper bound, so 0 and 1. So have a go, pause the video, and try and make a color variable that we can sync, and then assign it as a random color in the network manager. So I hope you paused the video and gave it a go. We just want to really repeat everything that we've done so far. It's really just the exact same flow. So we want to sync a color. Let's copy paste what we have here. Let's change it to be a color. That's the type we're using here, Unity Engine.color. And we'll call this display color, but I'll spell color the British way, like this with a U. And then rather than setting equal to a string, we'll set it equal to a color. Let's just say color dot, and then we'll use the default color dot black. And then down here, we need a method to be able to set the color. So let's copy paste this and just change what we need. So set display color. Just copy the word color. So new display color, display color, display color. And then the actual type coming in is a color. So now we need a way to call set display color in the network manager to then sync this between the clients. So if we come over here, after setting the name, we can then say player.setDisplayColor. And it needs to take in, as it says here, a color. And like I said on the slide, you do that by making a new color. And that color, you could just leave it like this and it's just, I think it just goes white with no alpha or maybe black with no alpha. But we want to set a random color. And colors are made up of RGB values, so red, green, blue. And those values here go between 0 and 1. So I'm going to generate randomly the 3 RGB values. So it's random.range between 0 and 1. And that's the first value. So then all we need to do is we need to go close this, comma, and then random.range between 0 and 1, comma, random.range between 0 and 1. And now we can just separate that onto some more lines so it's a lot easier to read, like so. And there we go. We could even, make the color variable on its own line so it's a lot easier to read. So we can say color display color equals, and then what we'll do is we'll cut this out so it's a lot easier to read. And then we can just pass that in here. So each value, the RGB values, are between 0 and 1, 0 and 1, and 0 and 1. So it's a random color, and then we set it. By setting it, it then sets it here, and it's a SyncVar, so it will be synced. Now let's end the lecture off by giving it a test. If we head back into Unity, you'll see on the player object, when it lets us click on it, we have a display color, which is just default black with full alpha. And what we can do is we can build the game and give it a test. Now that the build is done, we can host over here, and then we'll join as a client in the editor. Keep in mind, the actual player's color doesn't update, and there's no way to display their name in the game just yet. We'll be doing that in the next lecture when we trigger things happening based on when SyncVars get updated. So as soon as a new name or new color comes in, we can then change the material color or change a little name bit on the UI. But for now, we'll join as a client in here, and let's look at the players. So player 1 is player 1, and they've got some kind of yellowy, murky yellow kind of color. And then player 2 has this kind of greeny blue color. So there we go, it's worked, right? We've joined as a client, and we've had our color and names synced for all the other clients in the thing. If we were to leave as a client here and join back, notice how player 1 still has the same color because they didn't leave. Player 1 is over here. But player 2 now has been given a different color, so I can just leave, join back, and now player 2 has a different color, and you can keep going on forever. They keep getting a different color because whenever they join, they're assigned a new color. So yeah, that's it for this lecture. We have covered SyncVars and network behaviors. So now you know how to make a new component to stick onto a networked game object, and then have variables that you can sync between the server and the clients. There's a lot more interesting stuff we can do from here on out, and in the next lecture, as I said, we'll be actually updating the player's color and their name when they join the server. So I'll see you in the next lecture. Hello everyone, and welcome to this lecture where we'll be looking at SyncVar hooks or SyncVar callbacks. It'll be where we can actually trigger logic to happen when we receive new variable updates. So far we just store a name and store a color, but now we want to have stuff like this where we can host a server, be given our name to update on the UI and our color, and we can move ourselves to the side and let player 2 join, and they're given a name and their color, and both clients update the visuals of the renderer and the name text above the player. Let's get started. So since this video is all about doing things whenever variables get synced from the server to the clients, obviously right now, the server will say, hey, here's your new color, here's your new name, but nothing else happens, we just store the data, which is good, that's one step, but the second step is to actually do something. So with the name, we can update a little name tag above the player so everyone can see what everyone's called. And then for the color, we can actually update the renderer color so the player physically looks like a different color in the scene. Because right now we're just storing the data, we're not actually using it. And we want to only, change the color and update the name text when those variables change, and that's why we'll be using these callbacks. Before that though, we need to actually make sure our player can have those things changed. If we go to the prefabs folder and into the player, our player is currently an empty game object, a game object with, the network player script, and then a sphere underneath. And we want to change this sphere's material color, which is quite easy to do in code. We'll be doing that in a minute. And then for the name, we need some kind of text to display above the player. So to do that, let's right click on the player, UI, and add some text Mesh Pro. And it'll ask us, because we haven't done it before, to import the Text Mesh Pro essentials. Let's do that. So now we've got our text and our canvas, but for some reason the text is not a child of the canvas, so let's drag that on. And we need to make the canvas not be screen space overlay, because if we head back to the game view and we were to chuck in the player, we'll see this text at the bottom left, but we want it to be just above the player. So let's go back into the prefab, back to the scene, and let's make the canvas not be screen space overlay, but be world space. And now it's still absolutely huge. We need it to be just above the player over here. So let's make the canvas size maybe 2 wide and 1 high, and the X and Y be 0, 0. So now the canvas is centered on the player, and we still need the text to go a lot smaller than this. This is huge. So what we need to do is let's move it above the player by, let's just go for 1. And the actual text itself is currently a font size of 36, which is far too big. We've got to go down probably to about 0.3, and let's 0, 0. And actually to anchor this text element should scale with the canvas. So let's click on the anchors, hold down the Alt key, and then in the bottom right, it means it'll stretch width and height. So if we resize the canvas, it'll resize the text element too. And now for this, I'm just going to say center align everything. And let's say my name is, missing name by default. It'll look something like this. We could, of course, spend more time here making this look nice, but we're just here to learn the basics of Mirror. As long as you can see what the player's name is, and then when we spawn in the second player, we can just move them to the side and see their name. The whole point is just to get across the fact that the names are synced. So now we could delete this player from the scene and just make sure everything in the prefab is okay. We do have the name sitting above the player object. So I'm just going to leave that as it is, but I'm going to actually rename this as the text_display name. That's all we really care about. And now we can actually start writing some code to change this. Now let's start writing the code to update the name and the material color by heading back to Assets, Scripts, My Network Player, and we're going to need reference to the text element and the renderer so we can change them. By doing serialize field, let's gain reference to a tmp_text, that's the text mesh pro element, and if we call that display name text, like so, and then what we can do is we can hit control period and import tm pro, text mesh pro. That's that reference, and we also want reference to a renderer so that we can change the renderer color. So renderer, and we'll call it display color renderer, like so. And now we've got those two references, we can go set them inside Unity before we forget by going back to the player, dragging in the sphere to the renderer because that's the renderer we want to change the color of, and then dragging in the display name text to display name text. We can head back to the code, and now I'm going to show you how to do the color, and then you can have a go at doing the text. So what we need to do is we need to write the logic to actually update the color. So let's make a private void, and we'll call it handle, because this is going to be the callback method. Handle display color updated. And this method has to take in two parameters of type color. That's the way Mirror works with this. You've got to pass in two. So let's say color old color. Even if you're not using the old color, you still need to have this. And then color new color. Currently this method never gets called. We need to actually use it as the callback for when the color changes. So if we go up to the SyncVar here for display color, what we can do is we can add some brackets, some parentheses, and we can type hook. And by saying hook equals, we need to then pass in a string. So we can say hi, for example. It's not going to work. What it means is it's going to look for a method in here called hi, which there isn't, and it's going to call it. And that method hi has to have an old color and a new color. It doesn't have to be called old color and new color. It just needs two color parameters like so. And what it'll do is it will pass in the old and the new color. But as opposed to typing hi, we actually want handle display color updated. And you don't have to type it as a string like this because that could be tedious and you could slip up and type the string slightly wrong by one character and it would cause problems. So what you can do instead is you can say name of and then reference the actual method, which is handle display color updated, and that will work too. So now what happens is, as you'd expect, whenever the display color gets updated on a client, this function gets called down here, this method gets called, with the old color and the new color passed in. And with this new color, we can then update the renderer. One easy way to update the material's color is just to say renderer. So it's a display color renderer dot material dot set color. So we can set the color, and it wants to take in the string, which is part of the shader. We're not going to be worrying about shaders here. You just want to type in underscore base color, like spelled like this, and that will change the actual base color property of the material. And then the second parameter is the actual value, which is the new color, like this. Then now, whenever a client receives a new color, it will call this method, it will update the display renderer. So if we actually go back to Unity now, everything should be set up correctly on the player. As we see here, everything's referenced. We can now go build and run and test it. So the build is done. Now I'm going to hit host, and when I hit host, we should spawn in my own player object on the server and give it a color and update the color material. Keep in mind, the name won't update because we haven't written that bit of code yet. So let's host. We get this kind of greeny yellow color, and our name is still missing name, of course. And then if we go over into the editor and join as a client, It doesn't look like we're here, that's because we're just behind the other player. Let's move us to the side. We are a light blue. Now we don't see it moving down here. As I said, you know, the positions aren't synced. Though if I was to stop, and what I can do is I can host in the editor, move myself to the side, join as a client, and there we go. We've got two different colors. Obviously, they're kind of similar. Let's just join as a client again. There we go. But we see the colors are synced and are working correctly. Now we want to do the names. So your challenge now, let's stop this and head over to the slide. Your challenge is to update the player's name UI by creating a method to be used as the callback, the thing with the logic to actually update the text element. Add a hook, so just like we did with the SyncVar, hook equals name of and then the callback method. Then make the method change the player's UI text by accessing the display name text.text to the new name that was just sent from the server. Keep in mind, this callback method has to have two parameters, and in this case, they both have to be strings because we're changing a string. So pause the video, have a go at that, and I'll be back in a second. So I hope you paused the video and gave that a go. Let's head back into Unity. So what we need to do is just do the same thing again. So we need to make a method. So let's copy paste this for the name. Just spread this out evenly. And we'll call it handle display name. Whoops, don't want to change that. Handle display name. I've just messed up some of this. There you go. Handle display name updated. Taking in two strings. Remember, two strings. Old display name. Or I'll just call it old name in this case. Old name, new name. And then we don't want to change the renderer material color. Let's just get rid of that. What we want to do is we want to change the display name text.text to be equal to the new name. Quite simple. And now we just need to trigger this whenever the name changes. So we'll copy paste the function name, head up to the SyncVar for the name, and write hook equals name of, and then the name of the method. And that's it. That's literally all we needed to do. So now, whenever the display name is updated from the server, sync to the clients will then update their own text element accordingly. And let's go see if it works. So we'll head back into Unity, build, and give it a second, build and run, and I'll be back to show you it working in a second. The build is done. We'll host in here. We see we've got our name player 1. That's cool. But as I said, that's on the server. It's not as impressive. Let's watch it work on a client. So move ourselves to the side, join as a client, and then we see player 1 and player 2. Cool. So that's it for this lecture. You've learned how to use SyncVar hooks or SyncVar callbacks, whatever you'd like to call it, to trigger your own custom logic whenever a variable gets updated. Really useful for names or scores being updated or colors or anything really that you as a client get synced with a server. Pretty much all the time you want to have some kind of callback, whether that's to update the UI or do some other logic. For now, it's just display things, but as we move on to make the RTS, we'll be doing a bit more advanced stuff. So I'll see you there. Hello everyone and welcome. In this lecture, we'll be looking at how we can call methods from the client on the server and from the server on the clients. So we can do things like this. As we see here, we have a build, which is the host, which is the server and a client. And then we have just another client over here that's connected. I've moved the players each to the side so you can see them easier. And I can now, in the inspector, right click on the client and say, I want to set my name, which will set it to be my new name. And then by setting it, it actually has told the server that it wanted to set that name. So the server's updated too. It's overlapping, but you get the point. And then because it changed it, it then synced back and the UI updated. So that's what we're covering in this lecture. Let's get started. So what are remote actions? Well, remote actions is all about executing logic remotely. And by remotely, we mean not on the same machine. So you will have logic on your client, you playing the game. You do something like press a button, and that will then run some code on the server. That's remotely. It's not executing the code on your machine, you're telling the server to do it. And Mirror makes this really easy for us using remote actions. In Mirror, there are 3 different types that we'll be using all over the place, and as we go throughout the course, we can add a bit more complexity to them. There's some special use cases that we won't be covering now, it'll just make it a bit too confusing. We'll keep it really simple, and I'll go through the 3 different scenarios. Scenario 1 is where you, as a client, want to execute something on the server. This is useful for telling the server you want to set this value or you want to do this action. So in an FPS, you might want to shoot, or in an RPG, you might want to pick up an item. In, for example, this game, what we're making right now, we want to set our name. That's kind of universal. So we would make a function, a method, called command set name or CMD set name. It has to be capital C, lowercase md, and then the name of your function, so command set name. And in that function, you write the logic that you want the server to execute, such as setting the name variable, which, if you remember from what we've done so far, would then trigger a SyncVar callback and then tell all the clients what the new name is. So we can now set our name, or tell the server we'd like to set this name, the server does it, and then syncs all the variables. So by the end of this video, we'll have the full loop there. But one other requirement is that the function has to have the command attribute in the square brackets before the function. That just tells Mirror, hey, this is a command. So as I said, the clients actually call the function, the server executes it, so it's done remotely. Then there are scenarios the other way around where you want the server to execute some logic on all the clients. So, as you know, whenever a player spawns in, for example, we have those player objects that exist for each player. So even though I only have my own player object, I still, in my game, have the other player objects too. I know about the other players' existences. And how it works is those as network behaviors. Only network behaviors can do remote actions. You can't do it in a mono behavior. You have to use a network behavior, just like we are for our network player. And then with that, we can add an RPC method. So RPC is remote procedural call. And what we can do is we can make a method called RPC do something and stick on client RPC before it. So it's the same kind of way you do a command, just you change command to be RPC or client RPC. And then what happens is if the server calls that method, then all the clients would call that method, would actually execute it. So the server calls it and then all clients execute it. And then finally, in the other scenario, we have target RPC, which changes from client to target, and then you just change the RPC in the name to target, so the function is target do something. And then when the server calls that method, it actually only executes it on a specific client, not on all of them, on a specific client. And if you don't pass anything into that function, it'll just call it on the person who owns that object. So like I said, when we spawn in, we get a player object, and then we become the owner of it. So this would only be called on the person who owns that object. So that's it for the theory for now, though keep in mind, as I said, there's a little bit more you can do with this. There are some optional parameters and some settings with the attributes you can use. For now, we won't be using it, and we won't really be using it very often anyway. This will be good for pretty much everything we want to do. So let's head back into Unity and try and get the name setting working. So now we're back in Unity, we will go into our player script, and this is where we'll be setting our name. And we currently already set name, but the client doesn't have any say in it. The client doesn't request a name to be set. And when we build the proper lobby in the next part of the course, in the next section where we have our RTS, then we'll be able to allow the player to fill in their name, or we can grab it from Steam, or do whatever you like. But right now, we're not going to waste time building a UI to actually set the name. We'll just be doing it in code here in the client and having the server actually set it. So what we can do is we can write a method. So currently this is going to get a bit messy because we have server methods, client methods, it's all here, all mixed up. Let's split it up into regions. If you've never used regions before, it's just like right now I can compact this function, for example, by pressing this little arrow to compact it. I can do it with every function. I can do it with the entire class. You can actually make your own custom folders or regions, I guess you could call them. So hashtag region server, this is all the server logic. And then over here, I'll end region. And then it gives you a new little drop down. You can hide all the server code. And I'll be using this a lot. It's really useful when doing work with this kind of stuff. So you can make a region for the client. And you can then hashtag end region at the end here. And now it's all sorted out. So let's think about the flow of logic. We have the client and the server code, where the client says, I want to set my name by calling the method onto the server. Then the server will say, with that name, I will set it. And then in a future lecture, we can say, based on the name, I either will or won't set it. It might be an invalid name. For now, we'll just trust the client and we'll set it. So to do that, let's make the server method first by opening this back up. And if you forget how to do a command, it looks like this. Command attribute, then the function name begins with CMD. That's it. So we'll add the command attribute, and then we'll make a function, and it will begin with CMD. Then we'll call it set display name, taking in the new display name. We already have a method very similar to this, to set display name, but this one is only to be used on the server, whereas this method is to be called from a client. You can't call this one from a client. And then in here, we can just reuse our other method, set display name, and pass in the new display name. So the client calls this method, and then this method calls this method. And the reason we do this is then we can add some logic in here to say, if the name's not valid, then return. So this is where we'd actually do server validation. But for now, there's no validation, we just trust the name and we set it. And that's the server logic done. But now we need to call this method from a client, remember. So in the client code, whoops, close that. In the client code, we'll make a method called setMyName. And we can call this in the inspector for now because it'll take a bit too long to build some UI and get that all set up. We're doing a full lobby in the next part of the course. We'll be building a lobby for our RTS. So for now, we'll just get the name from the inspector as opposed to from Steam or from our own custom input field. And to call this in the inspector, you might not have used this attribute before. It's a really useful Unity thing to know. A quick tip, you can add context menu before a function, and then you can type in the name like setMyName. And let's also fix the function here so it's a void, doesn't return anything. And we can even make this private because we're only calling it inside this class. It doesn't matter that it's private, this will still work. It actually allows us, I'll show you right now, if we head back over into Unity, remember, this is called setMyName. I can even put spaces and then save, head back into Unity, give it time, and then we'll go to our prefabs when it lets us. Assets, prefabs, player. You can actually right click on the player script and you'll now have a button here saying setMyName. And if you click that, it will execute this logic here. And what we can do then is we can say cmd setDisplayName my new name. So for now, we'll just assume our player name is my new name. So when they join the server, their name will actually just be missing name. And then as soon as we right click and press that button for setMyName, it should then tell the server, hey, I want to set my name to my new name. The server will then up here say sure, and then set display name. And then by setting it, it will then trigger the SyncVar, and it will then update on all the clients. That is the full flow. That's pretty much as complex as it gets. You tell the server to do something, server does something, it syncs something, back to all the clients. It's a full cycle. So I think we should give this a go. Let's go back into Unity, build, and test it. Let's give it a test. So we'll host in the editor this time. So we've got ourselves player one, and we can move player one to the side. We can then join as a client over here. We get player two, we'll move player two to the side. And now what I can do is I should be able to go to the player I own. Remember, I don't own player two, I only own player one in here. So on player one, I can right click and press set my name. And by doing that, it will set my new name. And what do we expect? If we tab out, if we go back to the other instance, it should actually have updated showing that the blue player is my new name. And there you go. Obviously the name overlaps, it's a bit annoying. It's just because of how the scaling is here. Oh, no, sorry, actually, it's because when I move the player to the right and hit the inspector, you don't see it in here. We don't currently sync the transform. But it works. You can see that my new name gets synced because we told the server to set it and it synced it to the other client over here. And it works both ways around. If we were to host here, go to the client here, obviously they're overlapping. You can't see the other player, but if I was to go to the player I own in here, which is player two, and say set my name, the server sets the name, and then we see it here, it's overlapping my player name again, and the green player is behind. But it's fine, it works, you see, when we do it, it syncs between the two. Great, so now that that works, you've used a command. You now know how to, as a client, call a method on the server. So your challenge now is to do the reverse. There's nothing new, nothing hidden and fancy here. It's just the same format. You use the attribute, you start your method off with RPC, and then you call it from the server. So for your challenge, you'll be getting the server to call a method on each client. And the way to do this is to, first of all, create that method that will be called on each client. So that will begin with RPC, and it'll take in a string as a parameter for the new name, because that's what we'll be logging. And then we need to log that to the console. So in that method you just made, do a debug log to log that new name. And then on that method, for Mirror to actually recognize it as an RPC, you need to make sure it has the client RPC tag before it. And then finally, call that method from somewhere on the server. So we have some server logic to set the new name. Just add in another function call that calls this method you just made, the RPC. And what that will do is the server will then broadcast that to all the connected clients and tell them to run that method on their machine. Have a go, pause the video, and see if you can get this working. Welcome back, I hope you paused and gave that a go. Back over into Visual Studio Code. This logic will be executed on the client. So let's write it over in the client section. And we'll make the method a private void, and we'll start off, remember, with RPC. And instead of calling it RPC do something, we'll call it RPC log new name. Okay, this is whenever a new name is being set. And then let's actually take in the new display name. And we'll just say debug.log, the new display name. And then all we want to do now is finally remember to add the attribute on, so the client RPC. So this logic now exists, and we just need to call it on the server. It's as simple as take the method, go up to the server logic, and I said we'll call it whenever we set a new name, but before we actually do the setting. So right here, we'll say RPC log new name, passing in the new display name. And that's it. So now the whole flow of things is I set my new name, it calls cmd set name. We'll then RPC log the new name. So what that will do is all the clients in the game will log to their own consoles saying the new name. And then after logging the new name, it will actually set it and then sync it with everyone. So you've got down here a client calling a server function, and up here you've got the server calling a client function. So if we look at the slides quickly, you might be wondering, what are we doing with target RPCs? We're not actually using them now. Well, the example, we don't need to do another simple logging example. Target RPCs, the way you write them is just the same. You could quite easily take your client RPC and swap the word with target, swap RPC with target in the function name, and you're done. Obviously, the difference is it would be called only on the owner as opposed to on all clients, and that's it really. So I'm not going to make another example for that. We'll just get to it when we get to it and we need it. So to actually test this now, we should be able to go back to Unity, build, and give it a go. Now that it's built, if we host in the built version here and we come as a client in the editor, what we should be able to do is go to the console. And when I set my name in the client, remember this is the host and this is the other client. If I set my name in the inspector, it'll tell the server, I want to set my name. The server will set it. And just before it syncs it back, it will then actually log to the console saying the new name. And that is triggered by the server. And if this works, then it proves we've got the communication between the server and the client correct. So if I go to my player object, so I'm player 2 in the editor, so let's go to player 2 over here, right click, set my name, and by setting my name, it sets the name. You see it there, it overlaps, but it's my new player name, also my new name. Then if I tab back here, we see my new name, it's overlapped, but it's there. And if we go to the console, we see it logged my new name. Keep in mind, logging my new name is a client RPC. We actually call that up here in the server. So that proves that, as I said, the client can call a method on the server, and the server can call methods back on the client. And that's it for this lecture. You now know how to use commands and client RPCs and target RPCs. Even though we didn't use a target RPC, as I mentioned, it's very easy to just swap them out, and it's just a case of who it calls it on. That's the only difference. Commands and client RPCs are slightly different because obviously one's on the server, one's on the client, but client and target RPCs are both on the client. Ran on the client, called by the server. So you now know how to do logic both ways, when you want the server to do something and when you want the clients to do something. So now we'll be moving on to some server authority, because right now the server just blindly trusts and does whatever the client wants, but the server should be authoritative and be the boss and tell the client what it can and cannot do. So I hope you're looking forward to that, and I'll see you in the next lecture. Hello again everyone, and welcome. In this lecture, we'll be talking about and looking at some simple server authority examples so that when the player tries to set their name to be a name that isn't valid because it's either too short or has characters it shouldn't have or has blacklisted words, then we can just deny it and the server won't set it and it won't sync it with all the other clients. So over here, I've now changed, obviously we'll be going into the code later, I've changed a method here, set my name. It's not actually going to set a valid name anymore, it's going to set an invalid name. So by doing it, nothing happens. It tells the server to set the name, but player 1, player 2, it doesn't update. Doesn't update over here, it's still player 1 and player 2. And if I was to try and set the name for the other player, Mirror actually has built-in authority to just not set it either. And down here it says trying to set command for objects without authority because I don't own player 2, I'm player 1. And yeah, again, if I try and set my own name, it just won't change because it's not valid anymore. So let's get started. So let's have a talk about server authority, and we can use our code as kind of an example of server authority because we have some authorization in here without even realizing really, because it's done for us, but then we can also add our own custom authority. So the idea of server authority is just that the server authorizes what happens. Clients say what they would like to do, but the server at the end of the day decides whether you can do it and what the result of that is. The client will just press a button and tell the server, hey, I want to do this. That's most client code, is just telling the server what you intend to do. Most of the server code is actually doing the stuff. And in our case, all we have right now that we could even add to validation to is really the setting of the name. Because right now, we say, cmd set display name, and the server then sets the display name. It doesn't do anything else, it just trusts us. The string we're passing in could be any string at all. So we can add our own validation to check, is the length of the string, is it long enough, is it too short, does it contain words we don't want in names, does it, whatever. You can add literally anything you want. And that's for, validating the input, but you also might want to validate actions. So like later on, if we had attacking, imagine you play a first-person shooter. Just because the person clicked the button doesn't mean they're, CMD fire or shoot. Doesn't mean it should actually shoot just because they clicked. Because your game might have, let's say, ammunition and fire rate, and in that case, you need to check, are they allowed to fire right now? Have they got enough ammo? Is their fire rate, synced up? Like, are they able to shoot now? Have they shot too recently? That's all handled on the server. You can't trust the client for that, because the client could easily be like a hacked client where the code's modified, and their code will just call fire every single frame multiple times. So that doesn't mean the server should actually do it. The server will authorize saying, whoa, no, you're not allowed to do that. And Mirror, as I said, has some authority built in. So SyncVars are built and designed so that if a client changes it, nothing happens. If the server changes it, then it tells all the clients. So we know for sure when we get a SyncVar update, it has come from the server. So that's already handled for us. And we also have, for example, the actual object itself, this component, has an authority. It has someone it belongs to. Because when we spawn it in, well, when Mirror spawns in our player object, it sets the authority, the person who owns it, to be us, to be the person who it belongs to. And then later on, when we actually make more gameplay stuff in the RTS, then we can say we spawn in a projectile, it belongs to us. We spawn in a building, it belongs to us. We spawn in a unit, it belongs to us. And then because Mirror will store who owns what, and then it'll determine who can do what. So maybe, as you'd expect, you can only command your own units to move. So if you try and command an enemy unit to move, the server will say no. It just won't let you do it. So we need authority to stop cheating, but it also is important for just not getting confused on where logic is executed. Because if every client was in charge of dealing with their own stuff, then there could be many, many problems, because different clients could get out of sync. Imagine your game, you release a new version and one of the clients isn't on the new version, and then the code is just all completely messed up. At least with the server client, if someone isn't on the right version, well, first of all, you should have something in place to check that and get that sorted. But just assuming that someone was on a different version, it wouldn't actually break the game for anyone else, because the server would be, responsible for saying, your code is just wrong. I'm not going to tell all these other clients what you've done because you're on the wrong version. So like I said, down here where we set display name, it's kind of up to you whether you want to validate in here on line 25 here, or down here in line 39. It really is up to you, because the difference is if we do it here, we're only validating it being sent from the client. So we're validating what the client says. Whereas here we're validating what everything says, because we actually set display name right now over in the network manager when we join the server, we set the name. So depending on what you do, if you do it here, it'll validate it from the server itself and from the client, or down here, only the client. And the way I see it is I feel like it's best to do it here. It really doesn't matter in our case, but I would assume that if I have written some code over here for the server to set the name, then I don't care what the name is. I trust the server to choose a name. Even if it doesn't follow our guidelines, it's still the server doing it. Whereas down here, this is what the client wants. We want to make sure they follow our rules. So here's your challenge. I want you to write your own custom validation. It can be whatever you want, right? So I just want you to write your own validation for setting the display name, such as checking length, checking white space characters, special characters, blacklisted words. You can really go as advanced as you want here. So I understand the skill difference in people watching this might be quite varied. So if you want to keep it simple, just add a simple length check on the length of the string. But if you want to get a bit more advanced, have a go at making some, special characters you have to require. I mean, that's usually for passwords. So the special characters one doesn't really make sense unless you want to do it the other way around, where in your username, you're not allowed special characters. You might not be allowed underscores and asterisks and whatever, question marks, exclamation marks. And then you might have some blacklisted words, so people can't use, offensive like swear words or whatever other words. You can have that and do all those checks in there too. So really just do as much as you're comfortable with. If you're just comfortable with length, just do length. But yeah, have a go, pause the video and see what kind of validation you can get working. Okay, I hope you paused the video and gave that a go. As I said, you can really go as complex or as simple as you want. If you just want to check if the name's long enough, let's say your name has to be longer than 2 characters, so we'll just say if new display name dot length, if it's less than 2 characters, return. So we don't do anything if it's less than 2 characters. You could actually put this here, which would mean that you always log all the clients, you tell them all to log the new name before you then check what it is and set it. So it depends. I guess it makes more sense to validate the name before you tell anyone it. So it probably makes more sense to do it this way around. And obviously you can add more ifs here, so you can say, well, if the name's length is less than 2, or the new display name dot length is greater than, let's say it's too many characters, it's more than 20 characters, then return. I'm not going to bother adding any more complexity here because, as I said, it's really up to you. Let's just give it a test. So right now we always set the name to be my new name, and my new name is more than 2 and less than 20, so it's fine. So let's change it to be, for example, more than 20 characters or less than 2. So I'm just going to set it to be the letter M. So obviously the letter M is less than 2 characters, so it should return and not actually set the name and sync it with everyone. Let's go give that a test. Now that it's built, if we go host and then we go client, and let's just move the 2 to the side so we can definitely see if the name changes or not. What should happen is, in here I'm host, so I'm player 1. If I try and set the name now, whoops, right click here, set my name, it should try and set it to M, and then it'll try and do the server method, and it just won't work. It will reject it because it's too short. And there you go, it just doesn't happen. We look over here, it doesn't happen. It says player 1 and player 2. I know they're overlapping, but that just shows that we tried to do something, but the server didn't allow it. And obviously on here, we are the server as well with the host, but let's turn it around. It will do the same thing. So if we host, join as a client, move player 1 to the left and player 2 to the right. We are player 2 in here because we're the client. So if we try and set it, it won't do it, and it won't do it here either. It's still player 1 and player 2. So that's really it for server authority. It seems quite simple, and for the most part it is. It just depends what you're doing. It depends what you're authorizing. If you're authorizing setting a name, you probably only need to just validate the name. But for different things in your game, it can vary. So for right now, we validated what we need to validate. And as we build more, as we start building the RTS, there's more of validation. So we need to validate whenever someone tries to buy something, we don't just let them buy it. We check, do they have enough money? And we reduce the money for them. When they get buildings and units, we can't just say, oh yeah, you want to build that there, I'll just do it for you. It's same with placing buildings. We need to validate they're in range of other buildings or wherever they're allowed to build. So there's all this stuff. It just depends what you're doing at the time. So if you want more on server authority, then as we go through the course, you'll get plenty more of it. And that's it for this lecture, so I'll see you in the next one. Hello again everyone, and welcome. In this lecture, we'll be setting up a really simple level and some spawn points so that our players can join the server and be spawned in different places, as well as setting up transform syncing. So if I now move my player to the side, we can actually see it on the other client. And it works in all directions, so I can move up in the air, I can scale on the Y, everything syncs like that between the 2 clients. So that's what we'll be doing in this lecture. Let's get started. So right now in our project, we don't have any syncing of transform, so position, rotation, or scale. None of that is synced. Technically, it is when we join the server. So right now, if I was to host and join as a client, it's not synced, because if I was to move this player to the side, it's not seen over here. But if I was to then stop and rejoin, I'd get the position of that person. So I do see all the positions when I join the server, but then nothing gets synced afterwards. If I was to then move this now, to the right, I don't see that. No one else will see that. It's only done in the editor. And that's because there's no code we have written to actually sync the transform. Which leaves us with 2 options. We can either write our own or use a built-in mirror component that does the job for us and makes our lives a lot simpler. So let's go with the latter. Let's stop the client, stop the host. I can just stop the editor running and get rid of the build. So the thing we want to actually sync the position of is our player. So go to prefabs, player, and we want to add the component called the network transform. Whoops, network transform. We'll add that component, and we've got a few settings here. We don't need to go over the sync settings. I've already mentioned them last time. It's just how frequently this data is synced. So the settings we actually care about, like client authority, if I was to check this box, it simply means, like here, if the movement was to come from the owner of this object as a client, we'd still actually trust it. So normally you'd have only the server being authoritative. And then we have these sensitivities. So rather than syncing the most minute movements, it only syncs changes over the network when they are greater than, at the moment, 0.01. If an object moved 0.0001, it wouldn't be synced. And there's no really need for it to be synced. It's so small that it's just a waste of sending, data over the network. So only do it when it's a certain amount of change. And you don't have to worry about not being able to turn off rotation and scale syncing, assuming you don't change rotation scale. Don't worry about the performance, because if it doesn't change, it won't be synced. It's only synced if it is changed. And that's really it. There's not much more to that. So if I was to save the prefab, head back into Unity, and if I was to build now, I'd be able to show you in a second that it all works. So now the build is done, I'll host over here and I'll join as a client here. Let's hope the two player colors are quite different. They are. So I can grab this player now, player one, and drag them to the side, and you'll see them dragging to the side over here, which is exactly what we wanted. Now whenever we update the position on any of these axes, if we rotate it, you won't be able to see because it's a sphere. If we were to scale it, you'd see that change. It actually scales the text too, because the text is a child, but we don't actually care about scaling right now. Now you notice how when we change these values, in the inspector here, they snap, right? If I was to change scale to 2, it just snaps. Over here, it actually interpolates, which means it goes between the two, as opposed to just, let's say one time we send over the network a scale of 1, and then the next time we send a scale of 2. This client then doesn't just take in that new data and set it to 2. Over the next however many frames, it'll interpolate between the two and smoothly go there. And that's because we don't send network updates every single frame. You don't receive a constant stream of updates of scale, position, or rotation. You get them whenever they come. So you need to actually interpolate between the two, otherwise you get very jittery movement. If I was on one time when I send the data, I'm at 0.9, and the next one I'm at minus 0.9. Going from those two positions, rather than just snapping, it can actually move between them more smoothly, and it makes the whole experience a lot better. And as far as network transforms go, that's it. We don't really need to worry about anything else. It's simple. You just stick it on objects you want to be synced for their transform components. And by the end of this section in the course of Multiplayer Basics, we want to have our own character movement working where I don't have to drag it in the editor. Just like how we've already made it now, so I don't have to set names and set colors in the editor. It's all just done by the server. We also want clients to be able to move where they want. So we'll be adding that by using raycasts and navmesh agents. To actually move our player, we want somewhere for them to move. So let's make a floor. Let's just make something simple for them to walk on. So I'm going to make a cube by right-clicking, make a new cube. And I'm going to scale this up a bit. But our camera is currently, let's have a look in the scene view. It's currently down there and the cube's up here. So let's put the cube back to 0, 0, 0. And we can scale the cube up to be, let's say, 10 on the X, 10 on the Y, on the Z, on the Z. And yeah, the camera is basically in the floor. So let's move the camera up and back and up to 5 and back to minus 10, let's say. And then what we can do is we can take this cube and we can just tweak it a bit more so it fills up more of the screen. It doesn't actually matter too much about what goes on here. We just want some object here, the floor, for our player to move on. Let's rename this cube floor. And we also want some spawn positions, because right now all the players will just spawn right in the center on top of each other. And it would be nice if we could actually spawn them in some different locations. It would also be nice if we were to add a little more inconsistency here, so maybe you could add some boxes and crates and things. And I'll show you quickly how to do the spawn positions first, and then I'll be giving you a challenge to kind of have a little go at designing this level, though don't spend too much time on it because this is just a test for the multiplayer basics, and then when we build our RTS you can spend a bit more time there. So to do spawn positions, it's real easy. You just make a new game object, and you position it where you want the spawn point to be. So let's go 0, 0, 0. Just keep in mind this may be inside the floor, which it is, so we'll move it up to 0.5. Then now it's on level with the floor. And we can bring it over here. So one of the spawn points in this corner at, let's say, -5 and -5. Like so. And to actually make it a spawn point, we want to add the component network start position. And what Mirror will do, Mirror will grab everything that has network start position into a list of spawn positions or start positions. And when a new client joins, it will spawn them in at these different locations. So we've got one here, and then I'm gonna, in my case, put one over here on the other side, so an X of 5. Then I'll Control D to duplicate it again and put it at 5 up here. Control D, duplicate it again, put it -5 here. So I've now got these 4 objects 1, 2, 3, 4, these 4 different spawn points, all with these start positions on. And I'm going to just organize them in an empty game object called spawn positions, and shift select them and drag them in. And I'm going to leave them, well, no, actually, let's rename them spawn point. And then this can be spawn points. So mirror by default will spawn us in randomly. If we look down here in the network manager, it says random for the spawn method. So it'll take those 4 different places, and whenever someone spawns in, it will spawn them in at a random one. But we also have the option to choose round robin, which means instead of going maybe here, then there, then there, then there, and then there, just randomly doing it, it will actually go in order. So player 1 will go at the first one, then player 2 at the second, third, and fourth. And then if a 5th player was to join, and there's only 4 spawn points, it'll then go back to number 1 and just keep going in that cycle. So I want to go round robin for what we're doing. So now for your mini challenge, I want you to make the level more interesting. As I said, don't spend too much time on this. You don't even have to really do it if you don't want to. If you're happy with the complexity that I've gone to, then that's fine. Just maybe add some boxes, add some walls, and set up the spawn points from by using the network start position component. So just make yourself some spawn points all over the level. Maybe you only want 4 like I've done, maybe you want more or you want less. Just make it custom to you, and then pause the video now, have a go at that, and then I'll be back. Okay, I hope you paused the video and gave that a little go. We didn't really need to do too much there. Like I said, just add some boxes in. So for example, I'll just add another cube over here, and I'll reset it to 0, 0, 0. Bring it up to 0.5 actually, so it's not on the ground. We need to put it at 1 so it's on the ground. And then I can just hit the R key and scale this somewhat, let's say 4 by 4. And in the middle, we've now got this kind of obstacle that we can't just walk through, we have to walk around. And I'll also go back to my assets and into our materials folder, create a new material. And let's just call it mat, or like floor mat. Stick it on the floor, and we can make it some kind of green, and turn down the smoothness so it's not got this weird like shininess to it, like so. Turn that off. And then this object in the middle, I mean, you could leave it gray if you want. I'm happy with that. So yeah, that's my little level. So now that the game has built, I do want to mention one thing, which is when we join our player, if I go back to the scene view, our player is in the floor, and that's because their origin, their center point, is in the center of the sphere, meaning that'll be spawned on the ground where the spawn position is. So the 2 options we have there is either move the spawn positions up or move the player's origin down. I think the player origin down is the smarter option, because if we have players with different heights, then it'll still work. So I'll do that in a minute after we've played around with this. So let's just move it up to 1 for now, and join as a client here. Click the other player and move that up to 1 as well. So now we're both on the ground. And I can just move my player to the side, and we see it here. I can grab player 1, move them to the side. I can move them over here to the box. I can move them up to 2 so that they're on top of the box, like so. So now that that works, like I said, I'll just do the quick fix for you guys. We'll head back into Unity, we'll close the build, and what we can do is we can fix the player's origin by going to Prefabs, Player, Scene, and like I said, the player sphere is currently with the origin at the center. If we just move this up by 0.5 and save, we look back at the player now, the origin is at the base, which means the bottom of here will be spawned in on the floor, which is just what we want. Except now the canvas is a bit too low, so let's move that up by 0.5 as well. And everything is good to go. So I just rebuilt to show you that it does work. If we were to host here, join as a client here, you see the players are actually with their base on the ground. We can now move them both over here, and everything is good to go. So in the next lecture, we can actually add some input. So I can click over here and have the player move over here, and then it'll sync back the positions using the network transform component. So I'll see you in the next lecture. Goodbye. Hello everyone and welcome. In this lecture, we'll be finishing off what we've been making for this multiplayer basics prototype, where we'll be able to start and join in as a client on the server, so we're a host, join as a client over here, and click to move around, and actually have the player move, but the server's doing all the movement. This is the server and the client over here, but if I go to just the client, it's still requesting the server to do the movement, and it's syncing it back with a network transform, so both players actually see what's going on, and it works beautifully. That's what we'll be doing in this lecture. Let's get started. So we want to write some code to move our player using the navmesh system. Now you may never have used this before, I'm sure most of you have, but for those of you who haven't, what we can do is we can go to the scene and we can look at our floor. So our floor here and this wall are both static objects, which means they never move, they always stay where they are. So if I hold shift and select them both, and at the top right in the inspector you see this static checkbox. Now technically we only need to mark navigation static, but since they never move, let's just mark them as static like this. And now what we can do is we can tell the Unity navigation system to build us a nav mesh, or basically like a path around our scene to tell us where we can, or it's just doing some rendering, where it can and cannot go. And by it, I mean the player. So we can open up this navigation window, which if you don't see it, it's window AI navigation. And in the navigation window, we have a bake option. And without getting into the settings here, we can just leave it as it is. And if we hit bake, you'll see we now get this blue area. And this is telling us where our navmesh agents can go. And the reason why there are bits missed out on the side is because we have the navmesh agent radius. So if you imagine your player was standing right on this line, there'd be a bit of them on this side and a bit of them on this side. So the reason we have the radius is so that people don't, walk right up to the edge and have bits of them overlapping and, over the edge. And there's even a part on top of this box, but how we have it right now is fine because we don't want the player to go on top of this box. And because these two nav meshes aren't really connected, it's not like the player can just glitch up there. For now, the only place they can move if they're spawned down here is around this floor, which is exactly what we want. And to have something follow this nav mesh, we need to use a nav mesh agent. And an agent is just something that follows a nav mesh. So if we go to our player prefab over here, we can add on a component, the nav mesh agent component. Currently it assumes our player is kind of humanoid height. So let's scroll down to the default settings and put the height down because we are 1 unit tall. For what we're doing, it doesn't really make a difference because there's no like ceilings we have to go under, but this is fine, the radius is fine, everything looks good. So it's going to use this new kind of cylinder shape that you see to figure out where we can and cannot go on the nav mesh. And there are plenty of other options here for, as you see, speed, angular speed, so like how fast you rotate, your acceleration. All these values can be tweaked to your heart's content, and when we make the RTS, you want each of your units to have different values for these. So maybe the big tank accelerates slower or turns slower, those kind of things, and you might have some little mini cars that are like really, really fast and tiny and turn really fast as well. So tweak those settings as much as you like, but I'm happy with how this is now. We just need to write some code to have the navmesh agent actually move on the navmesh. So to write the code, we could either add it to the MyNetwork player script that we already have. We could just add in the extra things in here, but it's already getting quite big. It's about 70 lines long. Not too long, you could definitely do it in here and it'd be fine. But if you want to separate out your features, which I'd recommend doing, since this is just about the player's kind of presence on the network, they have a name and a color, and that's basically it. I'd like to keep that separate from any movement logic. So I'm going to minimize this and we'll head to our scripts folder as you see here, which already opened because I clicked on the script. And we can add a new C# script called player movement. And while we're here, we'll go to our player and we'll stick on the player movement script. Whoops, drag that on. And let's open it up in Visual Studio Code. And then your challenge for this video is quite early on. It's to set up the player movement script. This doesn't mean I need you to write the entire script, don't worry. But we want to create a new C# script, which I've already done. I'm sure everyone knows how to do that. And make sure now that it inherits from network behavior because we will be having calls to the server and back to the client. And then I want you to create an empty move command method. And I'm not going to give you all the information here unless you want it. So if you are able to go ahead and do this now to make a move command, it doesn't have to have any logic in it, just make a move command. Try and remember from how we do commands. And pause the video now and have a go at getting just this far. If you need a little bit of help with how to do the command, here's a little tip for those of you. Remember, naming with commands has to start with CMD. So if you have any problems or you'd forgotten, just remember the name of the function has to be CMD and then move. And then it has to have the command attribute before it. So this is all the information you'll need. Just make sure it inherits and make an empty command method like so. So have a go. Pause the video and I'll be back in a second. Welcome back. So I hope you paused and gave that a go. Let's head back into Visual Studio Code together and make this a network behavior. importing mirror, of course, and get rid of these methods to start off with, just start off with a blank canvas. And we want to make a command for moving, so private void cmd, remember that's the start with cmd, move. And for now we'll take in no parameters. And this is where I want you to get to, just network behavior, and make sure it has a command move function, an empty one. So remember, this command move will be executed on the server will handle movement. And for the server to actually move something, it needs to have the thing to move, which is the navmesh agent. So let's add reference, serialized field private navmesh agent, and we'll call it agent. And if we hit control period again, we can import, we'll have to go over here to the navmesh agent, control period, using unityengine.ai, that's where the navmesh agent is, it's in that namespace. We also need reference to one more thing, because the client will be using the main camera to actually figure out where we clicked in the world. There's a handy thing in the camera where we can take the mouse position and figure out where that would be in the world if we drew a ray. So what we can do is we can get reference to the camera. So private camera, main camera. We currently don't have reference, but we'll write some code to get it in a minute. I also like to organize, as I said in the previous one, so region, server, end region. That allows us, when it gets a bit bigger, to just close up the server code or close up the client code. So let's make a region for the client. Done. There's actually only very little server code in here, so let's get that done first anyway. We want to actually take in from the client where they want to go to. The server doesn't use the camera, do any raycasting or anything. It just is told, this client wants to go to this position, will I allow it? And if so, then do it. So where do they want to go? We have to pass that in. So let's take in a vector-free position. And with that, we have to then, we can't just say agent dot, and then there's a built-in method set destination position. We could maybe get away with this. The problem is the place they clicked may not be valid. This is what it'd be like without server validation or server authorization. It wouldn't test, is that place even valid? So we need to do a line before this to check if it's valid. So the way we can do that is by doing an if statement, because if they click somewhere that's invalid, we just want to return. We want to back out of this function. We don't want to set the destination. And this condition for whether they can or cannot go to that location will be determined by the navmesh. There's a built-in method called navmesh.samplePosition. It's a boolean, and it returns a bool, and we have to pass in quite a few parameters. So we need to pass in where do we want to go to, so position. We also need to pass in an out parameter, which if you've never used this before, it basically means we're passing in some data and it's going to pass some data out. So we want to get out, let's watch this, navmesh hit it's called. If I was to hit F12 on navmesh hit, it tells us we get back the position of the hit, the normal of the point that we hit on the mesh, the distance to the point of hit, and so on and so forth. So there's this struct here with some extra data in it that we get back out when we've done this function. And we also want to pass in our leeway, the max distance. So imagine you click 0.1 units away from the navmesh. You might still want to allow that to count, because it's very unlikely that your exact vector-free position is on the navmesh. It might be, you know, like 0.001 units to the side. You don't want it to just not let you move because of that. So we can pass in a leeway here. I find that just 1 works, so it can be whatever you like. And then finally the area mask, because there's different areas of the navmesh, but for our case we just want to use all the areas. And there's a built-in thing for this called navmesh, let's type navmesh.allAreas. But currently, this will return true or false based on whether it's a valid position. And we're saying if it's a valid position, return. Well, we want to say if it's not a valid position, then return. And right now, we're still using the position we got passed in to set the destination. We want to actually use wherever the sample position was. So we can take this hit variable and use hit.position, because hit has a position, which is where the hit was. And this will be somewhere that's definitely valid on the navmesh. And that's the server code for the navmesh. If we head down to the client code now, we want to get reference to the main camera because we will be using it. And we don't need to get it in start, because that means that all players will get the camera for all instances of the player, and it's just not necessary. We only need to know about our own player. So we can override, so public override. There's a method in here for on start authority, which is just simply like a start method for the person, for the client that owns this object, which is exactly what we want. So we'll only call it for us. And then what we want is, also I have to also put void because we're missing the return type. As it says here, this is called on behaviors that have authority. So we have authority over our own objects. That's good. We want to say main camera equals camera.main. So I'll go grab us the main camera and cache it. And finally, we want to use the update method to detect when we click and where we click. So let's make the update method. But you might notice one thing here. What is the problem with doing this? Well, the problem is the update method is called on the client and the server. So the server is now going to also be doing raycasting and everything, and it's going to be run. And even then, even if we only run it on clients, it would still be run on all clients, but we only want it to run on our client. So to stop it running on the server, we can actually add an attribute here called client callback, which is used for the Unity callbacks that always happen. So it prevents the server from running this method. The server will not run update, and no warning is printed. Because we understand it's going to try to run it anyway. Unity always tries to run the update method. But because it's like this, no warning's printed, and it stops the server from doing it. So this is now like a client-only update. And as I said, even though it's client-only, all the clients are going to run it. We only want to run it for our own player. So we can say if we don't have authority, if not has authority, we can then return, because it's not belonging to us. And because this is where we do movement, we also want to return if we didn't click, because if we're not clicking, then we don't want to move. So we'll say if not, and we'll use the default input system for now. We'll set up the new input system in the RTS. So we'll say input dot get mouse button down, and I'm going to use the right mouse button for movement, so I'm going to pass in 1. If you want to do left mouse button, it's 0, and middle mouse button is 2, I think, but I'm going to go with right click, so that's 1. And then we'll say return. So if we don't own the object, or we didn't press 1, then we want to return. We don't want to do anything. So over here, we want to then say, okay, now figure out where we actually click, because we know we've clicked because we checked the mouse button down for the right mouse button. So we want to find out where is the cursor right now. So we can say main camera dot, and there's this function called screen point array. So we pass in a screen point, aka where our mouse cursor is, and it will return a ray, which will be able to tell us where in the world we actually clicked. So we can pass in our input.mouse position, and we want to store this variable. So it returns a ray, as we see here. Let's make a ray and just call it ray for now. And then we want to do a ray cast, which will take the ray and actually cast it into the scene. It'll physically try and draw that ray and see what it hits. So we can say, well, physics.raycast takes in a ray, or well, there's plenty of overrides. There's 16 different overrides, but let's just try the ray method. So we'll pass in our ray, and just like with the navmesh agent, the navmesh sample position, it returned to us some data on that hit. We also want to get back some data here, so we can say out, raycast hit, and I'll call that variable hit. And then how far do we want to raycast to go? Well, we don't really want it to stop until it hits something, so let's say mathf.infinity. And this is currently just saying do the raycast, but we want to say, well, if the raycast hits nothing, that means they've just clicked off into the void of nowhere. That's valid. So we want to just return. So if not physics.raycast, then let's close that bracket and hit return. So finally, by getting to this line here, where I am now, we can now finally move, because we've said, all right, make sure it belongs to us, and make sure we press the right mouse button, and go grab where our cursor is, and then check in the scene where we hit. If we didn't hit anywhere in the scene, return. So finally, we know it belongs to us, we've clicked, and we've hit somewhere in the scene, which are all the requirements for us to actually move. So now we can say cmd move, once the position, hit.point. So this hit variable that comes back has a point variable on it, which is the point in the world space where the raycast hit. And finally, it's all working now. So we've got our server code and our client code, where the server just takes in a position and checks if it's valid. If it is, then it moves. And the client will say cache the main camera, and if it belongs to us, then find out where we clicked in the scene, and then tell the server to move us there. Let's head back into Unity. As I said, we've got the player movement script here. It'll now want us to pass in the navmesh agent. Let's drag that in. And yeah, that's pretty much it. Now that that's working, we've got the nav mesh agent, we've set up the code for clicking, we've got a main camera in the scene, everything should be good to go. Now that it's built, we can test if it works. So let's hit the host button and the client button. So if I select my editor here and I right click somewhere in the scene, if it's a valid position, the player 1 should start moving there. And because they'll rotate to face that direction, the nameplate will actually rotate, which is something we don't worry about right now. We'll fix it in the RTS, because we'll be doing the same thing for health bars. So if I click over here, the player starts moving over there. And I can click over here, I can keep clicking around. The acceleration is really low, that's why it looks like a drunk person running around and just spinning around everywhere. So it still works though, as I can see, click all around. And if I come over to this window and I click, now it starts moving this character. And there we go. So yeah, obviously it's not that interesting of a game, but we do have a little playable demo, I guess, where we can spawn in players, move around, and obviously if I decide I want to leave the game, it just leaves and I can join back as a new client. I get that corner as my spawn point now. I can then stop and come back as a client again and start in that spawn corner now, get a new color, still player 2, and I can just move around and do whatever I like. So yeah, that's it for this lecture. As we've seen over in the code, we've used all the skills we've learned here. Obviously, we didn't need any SyncVars, but technically we're using SyncVars with the network transform. It's just done for us. But we are using our own SyncVars for the name and color. And now we've got, using callbacks from the server and the client from the authority. We've got using attributes here for limiting the update to only run on clients. We're checking authority. We're doing commands to call methods on the server. The server's authorizing what the client's wanting to do and then doing the action if it's valid. So we've got everything working here that we need to start actually building a proper multiplayer game. And that's it for now, so I'll see you in the next lecture.